Hello, this is Team 516's control video. During the autonomous period, we detect the position of the capstone with an OpenCV pipeline. The image is converted to a YCRCB color scheme to account for changes in lighting and improve consistency. We have target encoder positions on the arm for the 3 levels and allow an error of 8 encoder ticks to prevent the arm from spending too much time adjusting its position. We outtake by setting the servo positions of the wheels in opposite directions. To reach the shipping hub and park in the warehouse, we use encoders to drive a precise distance in all 4 directions and turn at any angle with the inbuilt gyro. During the driver control period, we continuously cycle through freight by intaking and placing it on the top level of the aligned shipping hub. One of our main driver enhancements is a distance sensor inside the intake that lets the driver know whether a cube is nearby. The intake wheels automatically stop if the threshold distance is sensed. To drop freight, we have preset encoder positions for the 3 levels to improve time efficiency. In the event that the positions get reset, we included a manual control of the arm. This also allows the driver to adjust the position. Another feature is the touch sensor, which stops power to the arm as soon as it is pressed and resets positions. This way, the driver does not need to worry about the arm going too far down. A key algorithm is that after the arm reaches the target level, with just one button the outtake turns on and the arm resets back down, saving a lot of time and limiting the number of buttons the driver has to operate. In Endgame, to drop all 10 ducks from the carousel without any of them falling off, we use a trigger to allow for acceleration of the motor power when the duck is about halfway on the wheel. This minimizes the time spent, so we can place a duck on the shipping hub and park. Thank you for listening. If you have any questions, please consult our engineering portfolio or ask them during our interview.